And now we're at Chapter 8, Lesson 2. Essential question, how can different fractions name the same amount? Okay, and we're talking about prime and composite numbers. And we've got one of those handy purple boxes at the bottom that says, a whole number with exactly two distinct factors, one and itself, is the definition of a prime number. A composite number is a whole number with more than two factors. So examples of composite numbers are going to be all the even numbers because they're also divisible by 2. 4, 6, 10, 20, etc. Prime numbers 2, 3, 7, 11 are some examples. 1 is the only number that is neither prime nor composite because it doesn't have 2, it has only 1. Okay, so now we're looking at example 1. Blair is arranging 18 cupcakes on a shelf. Find the factors of 18. Use arrays to find the factors. So here we've got one row with 18 columns in it. So this would be 1 times 18. That's the first factor pair. So 1 and 18 are factors. This one, we've got 2 rows and 9 columns. So 2 times 9 would be the next factor pair. So 2 is a factor and 9 is a factor. This one, we've got 3 rows and 6 columns. So 3 times 6 would be the last ordered pair. So the factors are 1, 2, 3, 6, 9, and 18. Since 18 has more than 2 factors, it is a composite number. Composite number. Oh, how come there we go. It is a composite number. If we only had this array, if this was the only array that worked and making a grid, then it would be a prime number. So you might want to reference back this chart or mark this page, maybe dog-ear the corner so that you can come back to this page to remind yourself what is a prime number and what is a composite number. Okay, example 2, Sarah is at the park. She counts 73 kites. Write the factors of 73 on the kite. Tell whether it is prime, composite, or neither. Okay, so the factors of 73 are 1 times 73. It is odd, so I know 2 is not a factor, which means also 4 and 6 will not be. 3, if I were counting by threes, I would not say 73. So those are the only 2. Then 73 has exactly 2 distinct factors. It is a prime number. Prime number. And this one has exactly 2 distinct factors, which is what makes it prime. This one only has 1 by itself, only has 1 distinct factor. It is neither. And my fabulous computer writing. Okay. So pretty much when you're being asked, tell whether it's prime, composite, or neither. If it is even, this one is even because the number in the ones place is even, then it's going to be composite. That is one way to check off right away. If it's even, the ones place is even, it's going to be composite. Okay. Other thing you're going to look for, is it a 5 or a 0 in the ones place? Because that's going to be a multiple of 5. So this one is automatic composite because it's a multiple of 5. So the other thing you're going to look for is you're going to either use your multiplication chart or you're going to use your brain to figure out, what are multiples of these numbers and see if there's anything besides 1 and itself to tell that it's composite. If you can't find any numbers that multiply other than 1 and itself, then it is most likely prime. When you get to number 19, it says circle the prime numbers, cross out the numbers that are composite or neither. So most of your numbers should have a cross out because most numbers are composite, but every number should either have a cross out or a circle in this table, every one. So make sure you pay attention, look for numbers that multiply that have factors besides 1 in itself, and circle, cross those ones out, circle anything that's left, and you should have your prime. Write a prime number that is greater than 50. Write a composite number that is greater than 70. So you should be able to identify that. Okay, at the back, when you get to the word problems, the problem solving, question 22, what prime number is greater than 88 and less than 95? Now, at first, this can seem kind of overwhelming, but when you just persevere through it and you think about it, you'll realize that you've only got a few numbers that you're looking at. So between 88 and 95, that means 89, 90, 91, 92, 93, 94. And we're not even including 95 because it says between them. Now you know automatically you should be able to cross off half of these. And if you don't remember why, then you need to go back and start at the beginning of this video because I've given you some clues about that. And then you should be able to narrow down your options fairly quickly to determine which is the prime number of just these options that I've given you. Okay. Now this one, it's not only asking you, somebody's going to get really quick, oh, it's composite. Okay, yes, but that's not the only question. It's also asking you to list all of the ways, let's see if I can make this work. List all of the ways Ken can arrange the seeds in even rows. So you're writing the factor pairs like you did in lesson 1 as well on these lines. They didn't give you 3 lines just to write the word, whether it's prime or composite. Okay. Okay, so looking at 24, Susanna is making a quilt by sewing together square pieces of fabric. She has 36 fabric squares. Draw an array to show how she can create a quilt that has the same number of squares in each row and each column. So it's basically asking you, there is a doubles for 36. So the same number multiplied by that number will give you the same number of squares in each row and each column. So that's how you figure this one out. It's like you've done doubles addition. This would be doubles multiplication. Which number is doubled to get you 36? Okay, and then I'm going to leave you with 25. Do the best you can to figure that one out. And how are factors related to prime numbers? I want you to make sure that you do try this one because that is a great question. If you can get the answer to this, it'll show a lot of understanding of what we're doing through this chapter. So please do try to solve or write an answer for 26.